Our goal is just to get the site up and running in the fastest time possible, right? And so just kind of defining those things and getting on the same page is, kind of the first step that we would take in any of these. And then, of course, the site assessment, kind of doing like if it's an existing facility or existing community, doing a load assessment. And really kind of in this stage is like, it's the feasibility stage. It's like, can this project continue forward? And what's the sizing that we want to move forward? Like, are we going to do batteries with solar? Are we going to have a generator? Where do we connect? And then trying to define project costs and cash flow to be like, does this project pencil? And how does it go forward? And does it pencil from an economic perspective, or can it be funded from, maybe a grant perspective?
Getting the level of engineering and detail right in the RFP is critical. I was the president of the Washington Solar Energy Industry Association. I know the Washington solar industry really well, and we've put out a number of different RFPs that lacked, I think, in more engineering detail, because our assumption was that the industry would really want to have some kind of ownership of the design and engineering of these projects, kind of value engineering. And that was a bump and scrape that we took. We heard pretty overwhelming feedback from the industry that they wanted to see, more due diligence done on the front end, so they could get in and get out. And so, I think for us, like, not having hubris, but really recognizing this is still a new industry. And, the Big Beautiful Bill made it really clear in my mind that everyone is turning their gaze towards microgrids and energy storage. And so we really do have to think about how are we developing these projects that are supportive of the installers who will be building them and constructing them, while being representative of the industry. And unfortunately, in our experience, it's a balancing act that we have to throttle that kind of line to really get it right.
The importance of having a regular cadence of just like checking in on this is how the microgrid is operating, and from a programming perspective, looking at what the rates of electricity, if we're grid connected, for example, what the rate of electricity is, and if that rate has changed, if the structure has changed. Ultimately, the client or the microgrid, it's sitting on a dispatchable asset, and the conditions of the grid change year over year over year. And if you don't update it, like it'll still work and probably still meet the project goals, especially if it's resilient. But if there's an economic factor in that as well, not doing that is leaving significant cash flow on the table for the project, right? A small change of the utility rate, just maybe by an hour or two, if you take the time to update the programming, could be like 10, 20, it could be thousands of dollars of project revenue that could be realized just by having a cadence of updating that year over year.
There is so much that you need to do on the front end to ensure a successful project. And it's oftentimes, it's hard to see. That kind of social, economic, technical work is hard to see on the front end, but setting up the project for success is really critical. I like to say that we can do hard things together when we support one another. So having really excellent engineering partners like Mayfield, having really excellent EPCs, having really excellent engagement with the utility to understand interconnections and controls, and the fire marshal to understand safety and reliability. Like, it's critical. It's critical that you're taking these projects seriously and taking the time on the front end to really well optimize them and educate both the community, the stakeholders, and the installers on the goals of the project. And if you do that effectively, then what you get is this beautiful construction project that's going to operate for decades in service of the community. It's an island, literally an island microgrid in Orcas Island in the Puget Sound. It consists of about 134 kilowatts of PVDC, both ground and roof mounted. The BESS ended up is a 500 kW BESS that we derated to 199 kW to stay within the Bonneville Power Administration's interconnection limits. And it's got about a 1376 kilowatt hour capacity on the BESS. There's also a 150 kilowatt generator that went in new, several EVSE, level 2 EVSE chargers, and then a new interconnection. So the point of common coupling and isolation transformer, you can see kind of in the front, top and middle, all went in kind of line side of their existing three-phase equipment. So there was a lot of kind of electrical restructuring in order to interconnect this system, and a lot of engagement with Opalco, the serving utility, who was really excited and supportive of the project, as well as, obviously the site host.
They went to do a utility interconnection study, and the timeline for that was 4 or 5 years, right? So essentially just like makes the investment in the project non-feasible. So the way that they address that, or the way that we addressed it, is to do a microgrid. Essentially look at the microgrid as an option. It's like, hey, what combination of technologies would allow us to disconnect from the utility grid and get this built within 12 to 18 months timeline? Do the math on that, do a feasibility study, figure out the goals essentially economics, and it makes sense to do a microgrid on the site.